welcome everyone. Very happy to see you here this afternoon. My name is Jonathan. I'm the author of PySpark in Action, which is going to be published in early 2021. One of the reasons why I wanted to do that stream today is a lot of the material that's being heavily promoted and online and also in reference material, spend a whole lot of time talking to Spark from a Scala lens. I find Scala to be a great language, but especially for data scientists or people who have more familiarity with Python because of the trove of library, because of how easy the language is to write and get started. I found when I was learning Spark that the material was just severely lacking. I ended up guessing a ton of stuff, annoying a bunch of people. So today I want to share a couple of elements, a couple of functionality that I find quite fun. Don't hesitate if you have any questions, if you have something that you do not understand, I'll do my best to explain. So today we're going to work with a data set that is pretty standard. I think if I'm moving here, oh yeah, maybe before we get started, there is discount code for today for all the material on Manning.com. The discount code is TWIT Rioux 40, so TWIT RIOU 40. I'm going to put it towards the end of the streaming on the chat. It is for all the material on Manning. I mean, I know I'm biased. There's a ton of books that I'm already putting in my virtual cart. And especially for today, all of the print books are $24.99. So as a matter of fact, you have the option today to get PySpark in Action as an ebook for $23.99 or get the print book for only $1 more. So I really recommend you having a look, and I hope you're going to have as much fun reading the book as I have writing it. So with this, let's get started. I'm going to zoom in just because I know that my screen is potentially bigger than the small window that's available on Twitch. So today we're going to work with some data that I took from BigQuery. A couple of properties that are quite cool is the data is quite well documented, so you don't have to worry about does that column mean, what is the type of that column. So we're able to forget about this, focus really on the task at hand. So I'm taking the GSOD data, which is weather. If we are going up, there's quite a lot of them. But Google did a fairly good job at documenting what is the data set about. So it's basically a bunch of weather information for a bunch of stations. So they have data from 1929 all the way up to 2020. Because usually if you have already a copy of my book, this is a data set that we're using in Chapter 8, which talks about UDF and Pandas UDF. There is a connector that allows you to connect straight from BigQuery to Spark. I'm going to be using local Spark today because I don't want to spend too much time having a massive data set and us spending a couple of minutes just waiting for a progress bar to be over. But we're using Spark 3.0, and there is a bug in the BigQuery connector. Google's aware of it. There's a bug report. The next release is going to get that fixed. So rather than using an older version of Spark, which kind of defeats the point, I just downloaded the data in a CSV format, and you can do the same if you want. Basically, the moment that you have a Google account, what I did is I took 2015 all the way up to 2020, which is giving us approximately like a couple gigs of data to play with. So it's going to be over the memory that Spark is allocated. So that's going to give us a little bit to play with without going overboard. So I have 2015 all the way up to 2020 that I downloaded, as well as the station data that we're going to use to join. I'm going to keep this window there. I have a terrible memory. Been playing with this data set quite a bit, but I always forget which columns contain which information. So I'm going to refer to it quite a lot. So with this, let's get started. So I have my editor over here. I'm just going to launch a Python shell. Because we're not, sorry, there we go, Python, there it is. Because we're going to be doing mostly data manipulation, there's not, I don't want to show charts. I don't want to show a lot of information visually. I still think it's easier to use an IDE. I'm also much more comfortable. This is Emacs. It's just friendlier when you're coding. I know a lot of people like Jupyter. I would like Jupyter to have better key bindings, but everything that you're going to see here today is going to translate naturally if you're using Jupyter, even if you're using PyCharm, VI, Visual Studio Code. Maybe take a little bit of time. I am on Mac OS Catalina machine, so I've installed Spark locally using the homebrew approach, basically with a single command, brew install Apache Spark. You're able to get all the dependencies, everything set for you, which is very, very convenient. If you are on Windows or on Linux, fear not. There's clear instruction in PySpark in Action on how to install everything manually. There's a couple of dependencies. For today, if you're using, there we go. If you're using Spark 3.0, there is a little bit of a change that you have to do. And I'm just going to go and get the, there we go, user local seller, which is basically, I'm just going under my Apache Spark configuration directory. So basically, if you're installing Spark on your C drive or under your home directory, this is where you would go. If we're going onto the configuration directory, you're going to see that I have a spark default.conf that I've created over here. And there's two options at the bottom, Spark driver extra Java option and Spark executor.extra Java option. Executor won't actually be necessary because we're working locally, still very good practice to do so. There is a known mismatch between the version of Arrow and the version of Spark. If you don't set this parameter to true, you're going to get an ugly mistake the moment that you try doing an Arrow transformation. In our case, it's going to happen when you have a Pandas UDF. It's something that is like, there's like one sentence on the Spark website. The Spark maintainers are fully aware, but it takes a little bit of time. Basically, they're just setting you to set the -d io.netty .try reflection set accessible, but finding where to put it, basically you go on your Spark installation under conf and then Spark default. There's going to be a template file. Take this one, save it as spark-default.conf, and then add those two options. That's going to save you a lot of headaches, and it also will give you the opportunity to work with Spark 3.0 on more modern Java, which I found, anecdotal experience, to be much faster. All right, so with this, I think we can get started. First thing that I'm going to do here is I'm going to import PySpark.sql, from PySpark SQL import Spark session. All right, so the only day that I have people watching me type, I'm having a hard time getting my finger straight. So basically, I'm going to do Spark session dot builder app name. I'm going to call it Python and Pandas UDF. I'm going to set a configuration. I'm just going to set a little bit more RAM. My computer, by default, Spark will allocate 512 megabytes of memory to your driver. We only have the driver. So kind of a moot point, like you want your Spark to have a little bit more memory. I'm going to use 4 gigs today. I'm going to show you how it gets reflected into the Spark UI. It's going to be well enough. We can always go back if that's necessary. Get or create. There we go. There we go. And then because I'm lazy, I'm relying on Black to set up the code for me. And I'm just going to send a buffer, MSB, there we go. All right, so bunch of information that's getting printed. None of this is really important for us. Basically just warning us that we're using local. There's a little bit of information about org.apache.spark.unsafe, which is related to, you wouldn't get that if you were on Java 8, but since I'm using Java 11, they're warning, they're aware. I've done a fair amount of research on their Jira. It's something that they are working on, but it's not going to impact us in any way. And then just want to test, I have my Spark session over here. Alrighty, so now I'm going to go and read my data. So basically, what I'm going to do is, first of all, I'm going to write one file, and then I'm just going to union them all together. So basically, if I'm doing this, I'm going to do sample mple equal spark.read.csv. Today, I'm going to be extremely lazy. I have absolutely no intention of typing a schema by hand. There we go, and then gsod, and then gsod 2020.csv.gzip infer schema equal true. So that's gonna, with the infer schema, Spark's gonna go twice on the data, which can be pretty slow if you're working with a lot of CSV data. If you're using another format like Parquet or Avro, the schema is stored aside, which makes it quite fast. But because we're working with not a whole lot of data, we're going to be good. And then I want to mention that my first. There we go. I want to mention that my first row contains my header. R and S are really weird for me. I always confuse them. There we go. All right. So just going to take a little bit of time. We should see, I might just have, there we go. There's a progress bar that's going to happen. This is probably one of the most common thing when you're using Spark. I'll take some time while this is loading. It's going to take, shouldn't take much time. There we go. I'm still going to go on over here. I'm going to go on localhost.4040, which is my Spark server, Spark UI, sorry. And basically that gives us a ton of information. I'm just going to zoom in because I want to focus on some proper settings. So if we're going onto the environment, the only thing that I would say is quite important to look for over here. I'm going to go onto the Spark properties. You're able to see that the name of the app, Python and Pandas UDF, it's also here at the top. And then we have the Netty settings that I've set in my Spark default that are being done here. Oh, cool. Alrighty, so if we're looking at the bottom over here, this is my executors. I have a driver, which basically is my main node. As you can see, it is of course active. There's 8 cores. This is what my computer is providing. And then I have my memory. If you're looking here, I have 2.2 gigabytes of memory, gigabytes in base 2, not in base 10, that are set up. So basically, although I gave 4 gigs of memory to Spark, Spark still will keep some memory aside for processing. It's also going to keep some heap space. So you actually don't have all that memory for yourself. So overall over here, if you're interested, you basically take the 4 gigs, so 4 times 1024, you subtract 300, and then you multiply it by 0.6, and that's going to give you the 2.2. So I didn't fidget with the default. They're usually pretty good. And then if we look over here, we're able to see that there's actually 2 tasks that have happened. So basically, I've read the CSV the first time very, very fast to look the schema, and then a second time to get the data with the proper types. So trove of information, I'm going to refer to it at times. I find it to be extremely useful. And we'll walk between the code and the UI as we go along. All right, so if I look at sample, there we go. Print schema, there we go. All right, so we have schema, nothing very surprising. The types are not exactly the same as on the BigQuery. The year, the month, the day, I know for a fact because it confused me when I started working with the data, are strings, but they only represent numbers, so it doesn't make a whole lot of sense to keep them as string. What I'm going to do now that I have a good idea of how to read one file, I'm going to set up something that's going to allow me to read multiple files. They should all have the same schema. So we should be able to do a straight union. So I'm going to do GSOD equal. I'm going to do reduce, and then I think I'm going to have to import. Here we go. I'm going to do from func tools import reduce, and then I'm going to send that because otherwise I'm going to forget about it. And then so basically it takes a function, and then I'm going to do data frame.union, which basically going to take the first data frame, union it with the second, and then take that results, union it with the third, and then take that same results, union it with the fourth. So I also have to import data frame over here. I think it's in Spark.sql. There we go. Yep. There we go. Amazing. So, all right. So then I think I'm going to have to go to my nodes because I am not, reduce is something that I am not, it's the kind of stuff that you always have to remember. There we go. Where is it? Fun tools. There we go. It's over here. All right. So I'm going to do Spark Dot Read Csv. I'm going to put that into a list because I'm going to do a list comprehension over here, and then this, and then I'm going to do for year in range. So I'm doing 2015 all the way up to 2021 because the first boundary is lower, it's inclusive, the upper boundary is exclusive. So I'm going to do an F string, which users Jonathan Rioux GSOD, and then GSOD up year.csv.gzip. And then that should all work wonderfully. And then, oh, I have to put my options in for schema equal true, and then header equal true. So one of the danger that we have over here is I'm putting a little bit of faith in the consistency of the data. So because I'm doing a union, Spark is gonna expect that all of my files from 2015 to 2020 contain the same schema. But since I'm inferring it as I go, it's going to take a little bit of time. But also, if there's let's say, month for 2015 is an integer, and then for 2016, because of some rogue data in the CSV, it becomes a string, the whole thing's going to crash. So I'm going to see if this works fine. Otherwise, one of the things, we might go the manual way. There we go. Then we're just going to wait and see. It's going to take a little bit of time because we're basically working on 6 files. Some of them are smaller, some of them are bigger. And we have to pass twice on each file. So first time to infer the schema, and then second time to actually read the data. Stage 5, right? Making some progress. If we're curious, in the meantime, I can also go and then look at the job that is active, which is job number 5. There we go. And basically, what we're able to see is what is happening at the moment. So if I'm doing the CSV over here, I'm able to see what are the actual operations that are being done. I personally don't like this chart. I'll show you a better one, but that gives you also like how much time it is spending. Right now there's 0 completed tasks, so of course we're not going to see anything. But if we go on the SQL part, which is the CSV that we want to see, there we go. Just a moment. Oh, we're gonna have to wait until it's over. I see. I'm just gonna wait a little bit more. So now we're up to job 9. So basically each file becomes a job. So first job, we read a schema. Second job, we actually process the data. So you can see that one of them is longer. So there's one that actually requires us loading the data, and the other one to read the schema is actually quite fast. So we're at stage 11. So I think, if I'm not mistaken, we had 6. We started at 3. So it should go all the way up to 15. I'm really not a patient person. All right, in the meantime, one of the things that I'm going to do is I'm also going to read the station data, which basically contains all the information about station number, which country is it from, etc. Oh, see, over. There we go. So we have GSOD. So everything ran quick. I just want to see how many records we're dealing with. So I'm doing GSOD.count. Just going to wait until this is going to run. And in the meantime, I'm going to start station equal spark.read.csv. I'm actually not fast enough for Spark today. There we go, GSOD, and then station.csv.gzip. And I think this is how I call the file. Schema equal true. And then header equal true. All right, here we go. Alrighty, so now I can do this over here, up. All right, so, and then station, count, I'm working with 29, sorry, there we go, 29,752 records. On the GSOD, I still have a pretty respectable 23 million. So if we're looking at that data, we're probably, globally within the envelope, like, we're probably under 4 gigs for sure. But you have to take into account that that 4 gigabyte is not only for the data to stay in RAM, but also for the memory for the operation. So it's always a good, like, as a good rule of thumb, don't think that you're going to be able to max out the RAM on all your nodes. You probably need more than what you think, because processing takes quite a lot of memory, and especially when we're going to be working with UDF, there is serialization between the Spark native way of representing memory to something that's compatible with Python Pandas, which we're going to cover, which takes memory. So if we didn't put the 4 gig on top, I would have got it out of memory exception. 512 megabytes is not enough to process all that data. It would be the same thing with Pendous. Alrighty, so now, first thing that I'm going to look for, I'm going to go and get back my GSOD.print schema. And the first thing that I want to look for, and we're going to start with something absolutely simple, just because I'm able to show it in multiple different ways. Really, really cool. We're going to convert the temperature from Fahrenheit to Celsius. I'm Canadian, so in Canada, we have a very complicated relationship with temperature. Like body temperature and outdoors temperature is Celsius, but oven temperature is in Fahrenheit. So I get confused when I watch TV shows from Britain who are like oven at 180, but at the same time, I have no idea if 100 is hot or not in Fahrenheit. So because this is temperature, I'm going to put everything in Celsius. And we're basically going to start with the kind of very simple way of doing so. So for that, because I don't need all of the data, I'm just going to select a couple of columns. So basically, GSOD sample GSOD.select. And basically, I need 1, 2, 3, 4, 5, 6. I'm just going to select the first 6, GSOD.columns. And I want from 0, 0, all the way up to 7. Sorry, there we go. And, oh, there we go. There we go. Over here. All right. Column, oh, shoot, there we go. No amount of preparation can compensate for some typing errors. So if I'm looking at GSOD.sample, I'm able to see that my data frame is a little bit more manageable. It's also going to be We're able to go back to our GSOD eventually, and I'm going to be able to rename some of that stuff if I need to get more. But just because we want to work with a little bit more manageable data mentally, I'm going to use that sample. So the first part is I'm just going to have to remember, basically, I'm just going to put that as a comment over here. So basically, a Fahrenheit, so basically, if we want to have Celsius, it's basically, we're going to take Fahrenheit minus 32, and then we're going to multiply that by 5/9. So couple of aspects is the most efficient way of doing this is absolutely going to be to use Spark column arithmetic. So Spark SQL, when you're working with the data frame, regardless of the language, if you're using Scala, Java, Python, or .NET, you have a bunch of methods, and arithmetic is part of those methods that are converting to a highly efficient operations on the binary representation that's native to Spark. So this should always be your first point of call. Because today we're using an example and I wanted something relatively simple, we're gonna explore it multiple ways. But just for giggles later, we might just play around and time it using a very poor benchmark. And if I'm not, unless my cluster has some big problem, the native way should be much faster. UDF should not trail too far, but still. So first thing that I would do is GSOD sample dot select, and I'm basically going to select before that, I'm going to import PySpark.SQL.functions as F. So those two, just because I know we're going to use them quite a lot today, they are pretty much the backbone of doing data manipulation. So the PySpark.SQL.function contains everything. So you can refer to columns, you can do regular expressions, you can use conditional statements. Everything is sitting in there. If you're new to PySpark and you're new to data manipulation using PySpark, reading through at least all of the functions that are available, it's going to give you a tremendous overview of what's doable and what's not. And then types are basically how Spark refers to what is the column containing. So if you see here, for instance, you have integer. Actually, I'm going to use that because for here, so we have you have your integer, you have your string, you have your double. What the column contains is going to give you a direct implication on what's feasible and what's not. You can't really, for instance, add two strings in Spark. Or maybe not add, it's not a good example, but divide two strings in Spark. But you can have a regular expression to extract some data from a string. On the opposite side, it doesn't make a lot of sense to extract the fifth character of an integer, for instance. So using the schema, and you're going to see me type print schema a ton of time because I tend to forget what I'm working with. It's a really, really good way to remember. You don't see necessarily the data, but at least you know what you're working with. All right, so this I can remove. So I'm just going to send that to my REPL. Here we go. And then what I'm going to do is I'm going to refer to my column with the temperature. It's better if I do this. And then another thing that I'm going to do is fcall with the temperature minus 32.0 times 5 divided by 9. And I've put that in parentheses because I just want to alias my my temperature, because it doesn't make a whole lot of sense to have Spurt naming your column by itself. And then I'm just going to do a show just to see what's happening. So there we go. So basically, as you can see, like that was quite fast. Spart transferred the instruction, fully aware, like basically, it's able to do arithmetic. So we've used basically everything but the addition. And if I want to verify by myself, like, I'm just going to, there we go, just for priorities of operation. And that's actually there we go. And that's actually a very good point, because I actually forgot to put my parenthesis over here. So there we go. So that's going to make a whole lot more sense. So 28.72. There we go. So using shows by default 20 rows, which is quite enough for what we're trying to do. All right. So don't need to save that, because I'm going to be doing the same temperature quite a bit of time. First UDF, so which is basically took almost half an hour just to get there. So the first UDF that I want to show is the regular Python UDF. So it's you're able to create a function in Python and promote it to code that's going to work on the Spark engine. So how it works, I have a little quick diagram that I can show you over here. So it's basically on the left-hand side. So basically the column that you're passing, or multiple columns that you're passing over here, it's basically going to get split into individual records, and then those records are going to get converted, deserialized from a binary representation, which is hosted on the JVM, so Spark, Scala, etc. And then it's going to convert it to something that Python's going to be able to understand. You're going to process the record, then reconvert it to the Spark binary representation, and then bring it back. So there's a lot of stuff that is happening. So it is usually quite slow. And then you are left with regular Python code. So, regular Python, a lot of people, it's fast enough. But compared to Java, Scala, it is, of course, much slower. And when we're going to see it, compared to native operations, or even using, native Java or Scala UDF, you're going to pay in performance. But one of the advantage is it's regular Python code. It's really easy to test. You're able to really sanitize and make sure that it's doing the right thing. And if you're able to pay for that loss in performance, it's still a totally valid way to do UDF. So how do we do them? Basically, the first thing that we're going to do is we're going to define a function. So we're going to do f2c, and I'm going to call it Python just because I want my function. I don't want to have to rename them all the time, so it's going to be obvious that this one is done in Python. And basically, I'm taking the temperature as a double. I think it's float. There we go. And I'm returning basically a float. So for those who are not familiar with this was introduced, I don't remember, Python 3.5, I think. Those are type annotations. And when working with Spark, I find them to be extremely useful because it's kind of a contract that you're giving to yourself, saying that function expects a float and is going to return a float. So the same way that I was saying that looking at the functions and the type in a PySpark world gives you a blueprint of what's doable and what's not, when you're working with Python, Python is a dynamic language. It's really frustrating to write a function, realize that, oh, I did something funky, especially for more complex function. This is a poor example because it's pretty straightforward. But if you're doing something that does a lot of business logic, making sure like you're able to run a tool, and I'm going to show an example. Actually, I can do, like, if I do return blue, which is obviously not correct. If you're looking at over here, it's kind of a little bit disconspicuous, but like I have MyPy, which is a static checker for Python that says incompatible return value. I got a string and I expected a float. So it's very useful, especially when you're working with data processing, because Spark often, if it doesn't crash, what it's going to do is it's just going to put nulls everywhere. And when you're working on a big data pipeline, if it's running for a lot of time because you're processing a ton of data, there's nothing worse than, let's say you do your data cleaning and then you send to your machine learning algorithm and then it crashes because there's null somewhere. So anything that I can do ahead of time makes me very happy. So now what I'm going to do is I'm going to do temp minus 32.0 times 5, out of 9. And then basically this is it. My function is done, but it is a Python function. So in order to promote it as a UDF, I can either use a function called UDF, or I can use the same function as a decorator. And then basically, I have to pass the return type. So in this case, it's going to be double type. Python floats are PySpark double. So something to bear in mind, PySpark has floats, which are less precise than Python floats. So it's not going to break, but you will have a little bit of a loss in precision. So I'm going to send this down. So now, if I'm passing, I'm just going to go F2C Python. You're going to see that if I'm passing a parameter that's like, was my thing, 83.7, I'm going to get a type error. So invalid argument, not a string of a column. 83.7 is a type class float. So one thing that you cannot do when you're creating a UDF is it needs to be applied to a PySpark column that's going to contain doubles. So if you want to test it, you do same thing, F2C Python, and then there's a func attribute, which is going to return the function, but not UDF'd, for lack of a better term. So 83.7, and now this is going to work. So if you're using PyTest, or any other testing framework, and you want to be able to test your UDF, but you have decorators everywhere, just remember that the func attribute of your UDF will allow you to work on scalar data, and data's the same, so you're able to get a lot of certainty about your function doing the right thing without having to launch Spark. All right, so now what I'm going to do is I'm going to do the same over here. I'm just going to copy and paste this because I need to be a little bit faster. There we go. And then I'm just going to do the F2C Python. There we go. And I'm going to pass the column temp. And then I won't alias it today, just because I just want to see. There we go. And then up. What did I do? Oh. go. What's happening? Error at Python worker for types. I don't think I have. This is new to me. Okay, this is good. And then I just want to make sure GSOD sample. The temp is double. Yes. FTC Python. This is great. So that should all work. Why is that the code types? Oh. It doesn't make any sense. I might just have to. Import. I think it's because I named I named my types. T. No, so this one's good. It's calling an absolute. There you go. C Python F call. Temp. I need to do a select. There we go. Okay. What? Oh, it's because I have. Here we go. Just a quick moment. I think it's because I have. I have. There we go. I can delete this. There we go. I have a types. There we go. There we go. So I had a types.py that basically confused my import statement just because of the over here. That's news to me. I have the bad habit of creating some random files when I'm experimenting, and that's biting me today. All right, so if we're, I'm just gonna push that back over here, and there we go. So we have the exact same function that basically happened. PySpark renamed the function, renamed the column over here. So it's still catchable. I like to alias all the columns that I'm using, so I'm in control. But because we're experimenting, this is totally fair. So this is the easiest kind of UDF. It used to be the only kind of UDF that you could do. They're quite slow. This is what got kind of the reputation of PySpark to be really slow compared to Scala and Java until Pandas UDF came. So today I'm going to introduce a couple of Pandas UDF. So what they do instead of using regular Python code is they're transforming part of the PySpark data frame into a Pandas data frame. And then you're able to use highly optimized Pandas code that use vectorization on smaller chunks of your data frame. So you use Spark as kind of an orchestrator for Pendous. it's not as fast as using regular Spark, but it is much faster than using regular Python. There's anecdotal benchmark that says that PySpark UDF, Pandas UDF can be faster, but this really has to do on you know, your situation, like depending on your data layout, and so on. So for this, all right, I'm just gonna go and look, quick moment, there we go. All right, no questions yet. I'm going to create first Pandas UDF that's going to do exactly the same thing as we did before. So I'm going to import Pendous as PD. For those who are uncomfortable with Pendous, Manning has a very good book which is in writing at the moment called Pendous in Action. I use it constantly. I have a very hard time remembering the exact syntax for Pendous. My brain is filled with PySpark. I don't have enough room. So I found that book to be really searchable, very easy to use. So I also recommend it very much. So now what I'm going to do is basically I'm going to create a function. So I define my function over here, f2c Pendous. And then basically my temperature is going to be a pds.series. And then I'm returning a pd.series. So this is where MyPy is not smart enough to be able to say it's going to be a series of floats. So you have to be careful. Pendous has its own ergonomics about how they're going to process null values. So when you're writing a Pandas UDF, you're in Pendous territory. So let's continue over here. And then basically, as a matter of fact, Pendous uses arithmetics. So let's see why I should give myself some trouble. There we go. And then same thing over here. If you're, if I'm not mistaken, you use the decorator. I think we're going to get maybe a warning that it's getting depreciated still. So there we go. So this one, and then I'm exporting a double type. There we go. There we go. Yes. Up. So one thing, if you're using Spark 2.4, Pandas UDF is actually going to require you to put a type, and don't remember exactly which one it is, but I think it's you're going to have to write scalar in order to say that it basically takes a scalar value and returns a scalar value. With Spark 3.0, actually, Spark is smart enough to recognize that since you're taking a series and returning a series, it's going to be a scalar, scalar, Pandas UDF. So you're saving a little bit of keystrokes, and also you're adding some useful documentation. So you know, when you look at this, that could be applied to pretty much anything, but saying that it is a series, it makes it explicit of what you're working with. So, all right, there we go. I'm sending this. Invalid return type. Yes. Oh, there you go. Sorry. There we go. Whoop. There we go. All right. So if I do F2C Pendous, and I do func, it's basically going to tell me that it's taking a series. And I could pass, like, for instance, a series range. So basically F to C. So it's basically 32 to 213. And then basically we're able to see that it's 0 to 100. So quick way, we know that our Pandas UDF works, and then we can just apply it. So I'm actually going to be lazy again and just copy and paste this. There we go, up, paste, there we go, and then here we go, and then Pandas, up, there we go. Alrighty, and then you see same thing. This isn't a different way of doing so. So by default, when the big comparison, so if I go back to my beautiful visualization over here, so on the left, it's one record per one record. When you're doing a Pandas UDF, Spurt won't convert record per record. It's going to use arrows representation. So if you're interested, the Apache Arrow project is a way to represent data in memory. That's compatible with a variety of projects. In our case, Spark and Pandas both speak the arrow language. And it's going to chunk the data into manageable series. So by default, I think it's 10,000 records. You can change that depending on how much memory you have available. In our case, stay with the same. But it makes it faster because the conversion, you don't have to do to set up the for each record independently. You can do a full chunk. It's the same way if you're reading one large-ish file versus 100 small ones. It's always going to be faster to read the one large-ish file. So the same principle applies. One of the difficulty is it forces you to be proficient in both PySpark and Pendous, which some people can find a little bit confusing at times. But if you have some, let's say you've worked a pipeline on small data and you want to be able to apply it on a bigger data set, using those UDF is a very good way. You just add the decorator and you know it's going to work, which is pretty fantastic. So the last one that we can actually we can actually do is on that front over here is the iterator of series to iterator of series. So if you want, this is mostly used if you have to set up something. So you let's say you have a machine learning model and you want to distribute prediction. This is a use case that's more common. Of course, don't think I have the material to do machine learning today, but the examples still stay the same. So the only difference that we're going to be doing here is that instead of considering a Spark data frame as multiple series, we're going to consider that to be an iterator of series. So the first thing that I'm going to have to do is I have to remember where iterator comes from. So there you go, from typing import Iterator. So the typing module contains, just like we see float over here, it contains other types that are not as commonly used. So float, string, int are all going to be available by default, but iterator is something that's a little less common, and you're going to be finding it in the typing module. So over here, what we're going to do is we're going to do def def f2c iterator, and then we're basically our our temperature is an iterator of PD series, and it's going to return an iterator of PD series. All right, and then the only difference that we're going to have here is instead of returning, there we go. So what you're going to be doing is I'm just going to replace temp by temps with an S. So for temp in temps, and then over here, instead of doing return, there we go. Sorry. There we go. So I'm going to yield. And then basically, this one is going to be a little bit, there we go. Forgot to import my stuff. Got too excited. So this one is a little bit harder to test. You would have to create basically either a list of series. We're pretty confident that it works. I don't think that testing an iterator UDF is going to be that much worth it. And then basically what we have here is we just have to do an F Pandas UDF. And then we can put T double type, or you know, if you're really in a hurry, Spark is also going to accept the shorthand over here. You know, I'm not a huge fan of using this. I prefer using the object over here, first of all, because it's autocomplete. And then second of all, if you have more complicated schema, you can also build them programmatically. Oh, sure. There we go. A little bit bigger. There we go. And then I'm just gonna over here, and then same thing that's going to happen is we're just FTC, and then there we go. So there we go. So it gives all the same. So if you're looking at this, so basically we've seen 4 different ways of doing a relatively simple function. In practice, it's going to be quite apparent which one you want to be able to use. As a matter of fact, if you're working with other libraries, or you have to do an apply in Pandas, which can be quite slow, you can use a regular Python UDF and save yourself the trouble of doing some extensive testing or trying to work outside the quirks of Pandas. But if you have Pandas function that you want to promote, it's really, really easy. And then if you have, let's say, something that you have to instantiate over, it's a text size. It's a text size. There we go. I think it's pretty much the biggest I can do. If you need to use an iterator, it's going to be quite apparent, because you're going to have like kind of a seed that you have to start. So either a machine learning that you have to promote, and then you're going to be able to propagate that. So those are basically like one or more column that you're returning a single value. So number of records is important. You want to be able to return the same number of records. So some of the common mistakes that I see is if you do a series and you do a filter, well, PySpark is gonna, if you send 100 values and you get back 98, which records are going to bump. So the transition is not necessarily as seamless, and because Spark manages with big data, when you're sending a column, so let's say I'm sending the column temperature, well, there's only temperature that's going to get processed. It's not going to send the whole data frame just for the sake of doing so. So you have to be explicit, and you have to be careful about what operations you're doing. So The second one, I'm just gonna get my, there we go. This one I'm gonna have to actually make a little bit of a modification just because I do not have the same schema. I'm just gonna add a little bit of, there we go. Yes, it would be better if it was a comment. And then what I'm gonna do is it's basically call what's called kind of a group map UDF, which, you know, the scalar one are fine. You know, they do something that's really useful, but the group map has a lot to do with envisioning a data frame under a different lens. When I learn about them, I think this is actually the functionality that got me so excited about PySpark that I decided to go and write a book. I just found it so elegant and beautiful. So the concept behind this, and I'm going to go back to my chart over here. I'm just going to zoom in. There we go. There we go. My Miro's not really cooperative today. There we go. So you have your original data frame that basically is rows and columns. When we work with PySpark, we focus mostly on the columns. So what's going to happen on the on a group map transformation is you're going to give to PySpark a number of columns that you're going to want to process against, and PySpark is going to split your data frame into chunks. So each distinct set of columns. So let's say if we do, good example in our case, we're going to be using station, year, and month, because we're going to want to work with all the temperature for a given month for a given location. So it's going to create, conceptually, it's going to create one Pandas data frame for each of those combinations. And then it's going to apply our UDF, and we're going to transform a data frame into a new data frame. And then once that's going to be done, we just union them back or combine them into a single one. So it's actually quite powerful because you're not limited with what you want to do. And you're also, in this example, because you're passing everything all at once, you're not limited with how many records you need to bring back. So let's say, as an example, if you were to take your original data frame, you split it, it has, I don't know, 1 million records, you split it 10 way, so 100,000 records in each. And let's say your transformation reduced that to, let's say, 50,000 records. Well, your data frame is going to come back with only 500,000 records, and that's totally fine. So in practice, what does it look like? So what we're going to do is we're basically going to scale the temperature, but we want to scale the temperature independently per site. So let's say if we want to compute variation, or let's say we want kind of a very specific machine learning feature, and let's say we're training each site and each month independently, and we want to be able to showcase how, like in a given month, how what is the amplitude in a very simple way. We can actually split that. There we go. So I'm gonna do because I already have the code written over here, I think that I'm just gonna paste it, just because I also want to be mindful of the time. There we go. So we return the simple normalization for the temperature of the site. So basically, what we do is, first of all, I cache temp in order to avoid having to refer to the whole thing every time. And then my answer, my data frame with the answer is going to contain the station, the year, the month, the day, and the temperature. And then on top of that, I'm going to create a new column called temperature norm, which is going to contain my temperature once normalized. So if we think about this, and as a matter of fact, this is what we're going to have to do is the schema of the schema scale temperature. I'm just going to call it temp. So we're going to have, I'm going to go back and completely cheat OD sample, and then print schema. So basically it contains the station as an integer. So in our case, we an integer, and then the year as an integer, the month, mo as an integer, the day as an integer, the temperature as a double, and then the temperature normalized as a double. And then just because it's actually, there we go, I'm just going to make it a little bit more manageable. And then so we can see everything. There we go. Sorry, I'm there we go. All right, so if I look at my schema, there we go. I have oh, I have I don't like that. I do not want there we go. I'm just going to keep it like this. Otherwise, I could do a parenthesis and put my strings all one top of the other. But you know, for that, I think it's going to be fine. And then what I have over here, how do I apply this? Is basically I'm going to do GSOD sample. There we go. And then I'm going to group by. And then I'm going to group by the parameters that I want to create my my smaller data frame. So I want the station, I want the year, and I want the month. I do not want the day because otherwise there's going to be obviously just one observation. And then what we have is apply in Pandas. So this is something new with Spark 3.0. If you didn't, if you have Spark 2.4, you're going to want to use apply, and then your PySpark, your Pandas UDF. If you look at over here, I don't have a decorator on my UDF over here. I apply it in the function apply in Pendous. So I'm going to do scale, scale over here, temperature, and you don't have to pass anything, and then the schema equals schema scale temp. There we go. If you were to go away, if you were to apply it in the old way, just for those who are using 2 point something, so it would be the group by, and then you would do apply, and then you would apply the scale temperature over here. And then in the scale temperature over here, you would have to add an F, Pandas UDF, and then it would be, the type would be group map before putting the schema. So I'm going to pass all of this to PySpark, and then scale temperature is so defined. Temperature. There we go. All right. Schema scale temp, undefined name. Should have told. There we go. Group data has no applying Pendous. That's not true. There we go. All right. So one thing that I forgot to do is, of course, show, and then that would have been helpful in order to show some data. There we go. Now it's going to process for a little bit of time. Shouldn't take too long. Up. Just going to wait. So basically what we're doing is we're taking our 20-something million records, we're splitting them, and then we're sending that to be converted into a Pendous data frame, and then we bring that back all together. So as you can see over here, if you take the station, this is all of the data is a little bit all over the place because PySpark doesn't guarantee what records you're going to get. But if you take, for example, like on the 19th of February in 2015 at that station, actually that was the largest temperature for the month. So I could actually, if we're curious, year year equals 2015 and STN equal 10014, and the month equals 2, order by, we want to do da, and then we want to show, and you know what, I'm going to ask, I'm going to keep it at 20 records. There we go. So it's going to recompute the whole thing. Spart doesn't keep intermediate data lying around because, when you get to think of it, if you're working with a large amount of data, you don't want your RAM to be cluttered with experiments. So it's kind of a good compromise. If, for instance, GSOD sample, we could have cached it, but for the time that it takes, it's actually pretty good. And I usually have bad experience with caching. I end up always over caching, and my cluster crashed. So this works fine. I rather wait a little bit rather than having to restart the whole experiment. All right, there we go. And then the last one that I'm going to want to talk about is what's called the series to scalar. Should probably look at how it's pronounced, which basically is you're going to give series to Pendous, and it's going to give you back one value. So it can actually be any kind of value. If you look at the documentation in a PySpark, they're going to give you exactly what they can't accommodate. So there's more complex data types, like a list of timestamp, for instance, is not doable because of a limitation in arrow. But for the rest, it's very, very flexible. And the way that we're going to use it is I'm going to create a very dummy machine learning model and just extract one of the parameters. But this opens, we were talking about, you split your data frame, you split your PySpark data frame into multiple Pandas data frame, and then you pass some code. Well, that code can be fitting a machine learning model. It can be, if you want to do distributed grid search, and there's a ton of libraries, for Spark 2.x that were looking into compensating because it didn't exist at the time. But now it becomes really, really easy to set up with a minimal amount of code You have your machine learning model in PySpark, in Pandas, for instance, using scikit-learn. Well, if scikit-learn is installed on your cluster, you can consider all those little data frames, and they can actually be, you can have the same data set and then union and then add some columns, which is going to be what are the grid search parameters that you want to be able to explore. And it becomes a very kind of easy way to leverage Spark to do something that would be typically Pythonic, which I find really cool. This is taking quite some time. That's okay. We're just gonna let it fly at that time, and then I'm gonna go and there we go. I'm just going to apply this one. All right. Alrighty. So this is the last one. There's a couple more types that are being used, but they're very, very niche. I have yet to find kind of the killer app of why you would like to do that. So there's co-group, for instance, which is kind of a group by at the same time that you're doing a UDF. It's nice, but I have yet to find like the application where it's like better than doing the group by and then running the UDF. But this one's quite neat. So this one is actually I'm importing linear regression from sklearn linear model. Cannot go any easier than this. And then basically what I'm computing truly is a rate of change. So I'm going to give the day as a Pendous series and the temperature as a Pendous series, and I'm going to compute a float. And then basically what I do is I create the linear regression object on each for each group. I fit. So basically I use the day as my X and I use the temperature as my Y. I need to do a little bit of reshaping because of the way scikit-learn expects the input. And then I actually don't use a prediction. I just take the coefficient. So basically, like, it's a very fancy way to get, if you draw a line into your data without any other regard, this is what's going to happen. For this one, though, I think I'm just because this one takes quite a lot of time. This one takes even more time because you have to fit a model on each one of the partition. So I'm just going to I'm actually going to reduce the amount of data that is going to be used, but I'm actually just going to get over here. There we go. So I'm just going to walk you through that code while this is continuing to make its healthy progression. Actually over here, I'm going to use the sample. There we go. And then I group by station, year, month, and then I aggregate using the AGG. So for those who are familiar with grouping in PySpark, you can use count, you can use min, you can use max. But if you have more than one, or if you have a UDF that is that takes a scalar, that takes a series and returns a scalar, you're actually able to use the AGG, and I find the AGG method to be a lot friendlier. And then I pass my rate of change temperature, and then basically, I don't like this. I'm just going to call the columns directly. There we go, up. And then over here, F call, and then C as up. There we go. So I'm passing, actually, I don't even think I'm going to bother with the normalization for that purpose. All right. And then just for this, I'm just going to do GSOD sample equal GSOD sample where year equals. We're just going to take 2020, 2019. We'll take 2019 because it's a full year. All right. Actually, I think I'm gonna cancel this one, and I'm just gonna do it a little bit. Oh, it's because of the where and all that sort of stuff. That's the reason. We actually saw the results, so can go and it's because of the multiple filters, so it has to apply to everything. Yeah, I'm just going to cancel this one. I don't have enough patience. This is something, if you have more patience than I do, you can probably, there we go. And then this one I'm just going to cache because, there we go. And then if I do GSOD sample, it's actually not going to be that, it's not going to be that big. Over here. Here we go. Up, and I'm just going to put that up just so I don't have to copy this again. Here we go. All right. So a little under 4 million records. So I think this is going to be manageable. There we go. And then I'm just going to do that. There we go. And then I'm just going to do a result. And then show. And then we're going to let it rip. Oh, that was actually quite fast. Probably just because I'm asking for 20 records. So yeah, quick reminder, in PySpark, Spark is actually going to compute just what you need. So the moment that it realized that it only needs 20 records, the moment that it's confident that it can drop some computation, it will drop them, just because I've actually just asked 20 records. And because, first of all, well, the GSOD sample now is cached, so there's kind of a checkpoint there, but everything that I'm going to do on top of that is always going to be computed from scratch. So you don't have to worry about your data becoming inconsistent. You're just paying by waiting a little bit more if you have some operation that takes some time. So we can look over here, for instance, unsurprisingly, the temperature in 2019 for that station in particular, it was going down. For that station, it was going up, etc. But this is a very constrained example, but you can imagine that this is actually this can be actually quite powerful. If you have a pickle model, a scikit-learn model that has been pickled in Python because you've trained it and optimized it in Spurt, well, it's stored somewhere. So you can actually broadcast that variable, send it to all of your nodes, and then get distributed scikit-learn prediction basically out of the box without needing any code rewriting. So it makes it very powerful, and the only thing that you have to do is really internalize how Spark will convert from an operation to another operation. So we've seen record to record using the regular Python UDF. So one value comes in, or a couple of discrete value comes in and one value comes out. We can use a regular Pandas scalar UDF, which is a series comes in and a series comes out, but the application is the same. We can also use, what else did we look for? We can use the Iterator. So basically, if you have something that you need to set up and then you want to apply it the same way as the series to series, but without having to regenerate that very expensive object when you start, you can use the iterator approach. We've used the group map, which I found I really like. And then So the difference between the group map and the last one that we've seen, which is multiple series to a scalar, is the group map is going to take a data frame and then returns a data frame so you can have multiple columns. So although it's called a group by, it's not necessarily going to summarize the data, which is the reason why you have the apply in Pendous instead of like the traditional AGG, which is aggregate. And then the last one, it becomes basically an aggregation, which you know, you're using it the same way as you would do count, as you would do min, max. So rate of change becomes something that's totally applicable. And as you can see, using that approach, I don't have to order my stuff. I don't have to do any kind of fancy computation, regular Pendous code, and it's there. So that's it for today for me. So this is, you know, if you're interested, this is part of chapter 8, which is using user-defined function in the book PySpark in Action. There is a code today for 40% off. If you're using the, actually, I think I'm gonna just write it. Where is the, there we go. There we go. Code is small and barely legible. Oh, I'm really sorry. Is it better? And then also, you know, after chapter 8, you're gonna get in chapter 9 and then in chapter 15, we're reviewing a little bit the performance implication of various UDF. So I have a question. At the Spark AI Summit last week, Koalas was a big focus. Would this have been possible in Koalas or not at the moment? So Koalas basically gives you the opportunity to use Pandas syntax with PySpark data frame. All of that code would work in, like, this is regular PySpark code, so it's going to work if you're using Koalas. I would say I don't think there's a special syntax because, you know, you're having the same method. So, you know, the group by in Pandas and the group by in PySpark are obviously different, but it's just a straight up renaming. So of course it's going to work. But then, you know, the method AGG apply in Pendous, and, you know, the fact that you're using UDF, this is typical PySpark functionality, which you don't necessarily need a brand new syntax for that. So my assumption, although I don't frequently use Koalas, is that you would be able to use it straight up. So you can do your manipulation. So, you know, for instance, like where I would have seen Koalas to be applicable would have been, you know, over here. You know, instead of the select over here, there we go. I can actually just going to, there we go. Like instead of having the select over here, I think, and like it would have been like, and you could have passed like all of the, or even like, if I'm not mistaken, it would have been like GSOD columns, and then the same thing like this, and then that would have worked equally well. So it's more for the primitive data manipulation, you know, everything that you would see like with stock PySpark. Those application, I would say, there's no real point to have a different syntax. I think it's pretty clear, and there's no equivalent in Pendous that would warrant, like, you don't necessarily have the concept of splitting a Pendous data frame into multiple Pendous data frame within the Pendous library. I'm sorry for the for the code I hope you know all of that code is available in the book as well. If you're really curious and you want to have a peek, I know Manning is also offering, you can click on the book and you're going to get into the live book, which is going to give you a couple of sections. Yeah, I'm very happy I was able to do that. It's my first time twitching. I'll go and watch to see. Yeah, it's actually quite small. I look forward to do it again. There's a couple of new things in Spark 3.0 that are quite interesting. If you had the opportunity to be at Spark Plus AI last week, it was 2 weeks ago. It was there's a lot of exciting announcement with Spark 3. Python is, dare I say, taking over. So the fact that you can use Pandas really seamlessly with PySpark now really gives you no excuse if you're a Pandas data scientist and you're very comfortable with this. Promoting your code to PySpark is quite easy. So wish you a wonderful night, and yes, see you soon.